Alright, so I'm Noah K, and today we're going to be solving the 2010 AP Calc AB FRQ number 2. Let's jump right into it. A zoo sponsored a one-day contest to name the new baby elephant. Zoo visitors deposited entries in a special box between noon t equals 0 and 8 p.m. t equals 8. The number of entries in the box t hours after noon is modeled by a differentiable function e for 0 is less than or equal to t, which is less than or equal to 8. Values of E of t and hundreds of entries at various times t are shown in the table above. So there's our table, and let's jump into part A. So part A is asking us to use the data in the table to approximate the rate in hundreds of entries per hour at which entries were being deposited at time t equals 6. And it wants us to show the computations that led to our answer. Alright, so if we take a quick look at our data table, we're going to find that it's not giving us t equals 6. It gives us t equals 5 and t equals 7, but not t equals 6. So what we can do is approximate e prime of 6 as the secant line. And we're going to do e of 7 minus e of 5 over 7 minus 5, which we're going to find is 400 entries per hour. And if we take a look at our answer key, we're going to find that that's exactly what the folks over at the College Board did. They did e prime of 6 is approximately the secant line, e of 7 minus e of 5 over 7 minus 5, and they got 400 entries per hour. And as you can see, you just get 1 point for the correct answer, but you need to show some sort of process of how you got there. And you need to notice that they don't expect you to create any sort of equation with the data. You just need to do this 1 point for the secant line. And there's been a graph like this every year, if you see in the top right, with the same 1 point question. You just need to analyze the graph with the two closest points to what they're asking for you. Alright, part B, use a trapezoidal sum with the 4 subintervals given by the table to approximate the value of 1 over 8 times the integral from 0 to 8 e of t dt. And using correct units, explain the meaning of 1 over 8 integral from 0 to 8 e of t dt in terms of number of entries. So if we look at the bottom left, we see that that's how to do things with trapezoids, and that's what we're doing here. So first we're going to approximate that. So we're going to put the 1 over 8 to the outside, and we're going to multiply it by our trapezoidal approximation. So we can't use the shortcut for the trapezoidal sum, but what we can do is, since it says note if not equal widths, then find the area of each trapezoid individually and sub them up. That's what we're going to do. So we're going to find the differences between all of our x's, and we're going to add the two e of t values to create 4 different trapezoid sums. And then when you do that calculation, you're going to get 10.687. And then for the second portion of this, how to explain the meaning, we say that 1 over 8 of the integral of times the integral of 0 to 8 e of t dt is the average number of hundreds of entries in the box between noon and 8 p.m. So if you think about that, that makes sense, right? Because the integral portion is the trapezoidal approximation, if you look at the bottom left, and then 1 over 8 is our change from 0 to 8. So if you multiply that area times the change in x, what you get is the average y that we're going to be multiplying by the change in x. Alright, and then if we look at how the folks at the College Board did it again for part B, we're going to see that they did it similarly, and you'll note that there's 3 points that were given. So they did the trapezoidal sum, which is what we did, and then they found their approximation. You can see you could have said 10.687 or 10.688 and still gotten the point. And then you can also see that they had the same meaning that we had. And so, but let's say you were sort of confused about this. You want to get some points. So if you didn't know how to do the trapezoidal sum or approximation, look at the meaning and try to interpret what that is. You can find what that is, and then you'll get points. And just look at the tables in the values in your table to try to figure out what are they possibly trying to ask you and how you can use the numbers that you have in order to try to get some points. Alright, so for part C, At 8 p.m., volunteers began to process the entries. They processed the entries at a rate modeled by the function p, where p of t is t cubed minus 30t squared plus 298t minus 976 hundredths of entries per hour for 8 is less than or equal to t, which is less than or equal to 12. According to the model, how many entries had not yet been processed by midnight, which is t equals 12. All right, so if we think about it, the integral from 8 to 12 of p of t dt gives us how many are processed, but we want how many are not yet. But first, let's find out how many are processed. All right, so since this is a calculator active question, we're going to want to use our calculator to help us. This is TI Inspire CAF, so we're going to be using that today. All right, so we're going to want to find the integral, so we're going to press Shift plus, and the integral is from 8 to 12 of p of t. So we're going to type in t cubed minus 30t squared plus 298t minus 976 with respect to t. Press enter, and what do we get? We get 16. All right, so now that we know that it's 16, we can look at the question again, and oh yeah, we can see now 16 is how many have been taken out. And if we look at our table, 23 were put in. And don't confuse yourself putting hundreds to one of them and not to the other. Just keep it simple for here. We're going to do 23 minus 16 in minus out in order to find out how many are still in. And we're going to get 700 entries have not yet been processed. And if you look at how the folks at the College Board did it, they did it similarly. And let's say you ran out of time, you could still do this by hand. And notice that you don't get extra points for doing work with the integral. It's on the calculator portion, so they allow you to be able to use your calculator to computate things. All right, so part D, it's asking us, according to the model from part C, at what time were the entries being processed most quickly, and justify your answer. All right, let's think about that. What does most quickly mean? If you think about that, most quickly means when the rate is the greatest. Okay, so knowing that, if we look, we're going to need to justify our answer. So if you graphed the function, you would see that this is the graph here. And between 8 and 12, you would know that it's 12. But you need to justify your answer. So how would you do that? Well, you know when the derivative is equal to 0, that's when there's those possibilities where there could be an absolute max. So what we're going to do, we're going to set our derivative equal to 0. All right, so once we've determined we want to set the derivative equal to 0, we're going to use our calculator here, press Shift minus for the TI Inspire, d over dt, put in p of t, which is t cubed minus 30t squared plus 298t minus 976. Press enter, we get what our derivative of p of t is, and we're going to set that equal to 0 using the solve function. We get the two t values, and we're going to get, after finding it, we're going to get t equals 9.1835 or t equals 10.8165. All right, so now we have those two t values where we have the derivative of p of t is equal to 0. So once we know that, we plug those two values into the p of t, and we get this little table of values here, and this is what we're going to be writing down. And we're going to find that the p of t is greatest when t equals 12. And we're going to write this little summary statement here. Entries were processed the quickest at time t equals 12. And if you had no idea about part C, try to use part D to help you. Know that some sort of derivative or integral is very likely to be needed, so try to figure out how you can use that information to help you. All right. And let's see how the College Board did it. 3 points, one for setting p prime of t equal to 0, one for identifying your candidates, which we did, and one for your answer with justification. So see, there's no need to show excessive work when your calculator is active, no need to display any sort of graph. It's just straightforward. And so great job. Here's some recommended practice. Do it, have fun with it. Good luck.